All right, so another question you may be wondering is why are we learning this now, right? So it does have some real world applications, but what does this have to do with quadratics? We're in a unit with quadratics where we've just been graphing and factoring, graphing parabolas and factoring quadratics. So why are we learning it now? So remember that we had a problem like this in the last lesson, this exact same problem. And remember that one way we could do it is we could factor this out, right? So I could say it's a difference of two squares. So I could say x plus 10, x minus 10, and then my answers came out to be x equals negative 10, x equals positive 10, right? Okay. So another way I could have done that is using what's called the square root property. So what I could have done instead of factoring, since there's only one x and there's not a, since there's only a, one x term and there's not a regular x term, there's not a linear term, I can actually isolate this. So what I can do is instead of setting one side equal to 0 and factoring, what I can do is I can add 100 to both sides and solve for x, right? So I get x squared equals 100. You probably did a lot of this in geometry with the Pythagorean theorem. So then now what I can do to get rid of this square is I can take the square root because they cancel each other out. And the square root property says if you take the square root of both sides, you have to put a plus or minus here, right? For the same reason that we talked about with the principal root, and when you take the square root of 4, there's really two things squared that equals 4, right? There's negative 2 squared and positive 2 squared. Same thing here is there's two things squared that equal 100, positive 10 and negative 10. So that's why you put the plus or minus here. Okay, so when you take the square root of both sides in an equation, then make sure you put a plus or minus in front of it, okay? You didn't do that as much with the Pythagorean theorem because you're talking about triangles, and lengths of sides of triangles are generally positive, right? You don't have negative lengths, and so you may not have looked at that very much or put the plus or minus there or use that. But when we're dealing with kind of general algebra equations that don't have necessarily physical world context, then we include the plus or minus. All right, so that's how you can do that with the square root property. Now with this, we can do the same thing, right? It's not a difference of two squares, so we can't factor it, right? Although there is a way to do it, and you can see it in the book. They show how to factor this, but I think it's a little easier to use the square root property, a little more intuitive. So it's not a difference of two squares, it's a sum, so I cannot factor it. So what I'm going to do is I'm just going to solve for x squared, just like we did over here. Okay, so I'm going to subtract 100 from both sides. I'm going to get x squared equals negative 100. And now I'm going to take the square root of both sides. Okay, and don't forget the plus or minus. So the square root and the square cancel each other out. So we just get x equals plus or minus. And now we need to simplify this radical, right? So I have a negative in there, so I'm going to pop an I out. Okay, and then the square root of 100 is 10. So it's going to be plus or minus 10i. Okay. And so this, if we were to graph this on our calculator, it would be facing up and above the x-axis. And so there would be no real solution, but we just found a way using imaginary numbers to find a solution, right? All right, so that's how we use the square root property to solve quadratics. Quadratics where b equals 0, right? And we can find now complex solutions, right? Or in this case, a pure imaginary solution.